Hello. In our last episode, we spoke about the lime cycle, and today we're going to kick off with the second in this series, and we're going to talk about different types of lime. But today you may think, where is he sitting? Well, I'm actually at Blenheim Palace, out in Oxfordshire, and I've come here for the day, so I thought I'd record this in the nice sunshine in front of this beautiful building, a building, of course, constructed of stone, but with lime mortar. So in this episode, we're going to be talking about the different types of lime that you might find and might use in conservation projects. I'm going to go back to speak to Rich online, and we're going to have a talk about this. So see you soon.
Hello and welcome to Talking Conservation,
the podcast all about conservation of old, traditional and historic buildings and sites.
With me, Rich Aylesbury.
And me, Stephen Boniface.
So last time we looked at where lime comes from. So from limestone to quicklime to slate lime, then finally back to calcium carbonate within the wall. This video's focus is the lime that we end up isn't always the same. So depending on how the lime was made and what was in the raw materials, ends up with how lime behaves, and that is different. This matters in building work, especially in conservation, because performance characteristics do vary. How it sets, whether it's with air, with water, how strong it is, how well it manages moisture, and also how flexible or rigid it is once it's actually cured and finally gone hard. So here's an analogy for you in terms of what helps, I think, visualize the different types of lime. So imagine you're baking a bit of bread. You've got sourdough, and then you've got your commercial yeast bread. So you're kind of like your traditional white breads that you buy from a supermarket. They both rise through fermentation, but one's actually quite unpredictable, flavorful and made with natural starters, i.e. the sourdough. The other is consistent and fast, but different in texture. Lime works in much the same way. A traditional lime is natural, slow, adaptive, uses an unknown quantity of fermentation and yeast and rising, whereas the other one is very consistent, is engineered, and then you have the speed and consistency of how that bread is baked. I hope that's a useful analogy. Anyway, Stephen's now going to kick us off with starting with the most traditional form of lime, which is air lime, sometimes called fat lime or lime putty. Over to you, Stephen.
So, air lime, what is it? Well, if you remember back to the lime cycle, what it is calcium hydroxide. Now, this is made from pure limestone or chalk or a source of calcium carbonate. If you remember, what I said last time was it sets by releasing the water into the atmosphere by evaporation, etc., but taking on carbon dioxide. And in effect, it becomes calcium carbonate again. So its properties, though, are that it takes a long time to do that. So it's slow setting. Now, that has some advantages in that you can work it more. If you're dealing with plasters, you don't have to worry about getting it perfect from the off. You can work it with pointing. You don't do it all in one go necessarily. So slow setting is one thing, and it is in some ways advantageous. However, that needs to be controlled, and we can talk about that some other time. Now, it's got a low compressive strength. Now, what does that mean? In other words, if you put a lot of load on it, it doesn't take that load very well. So it's going to, if you like, squidge out. It's not going to be able to sustain heavy loads. So although historically you will see some very large buildings that have been built with an air lime, generally speaking, the amount of lime, if you look at the stone or the brick, it's actually a very, very thin layer, because all it's there is a bedding. It's no more than a bedding. It's not there to take any load. It's almost just to provide a minor separation. And that's how historically they were able to build big, tall buildings. But if we look at our typical, if you like, Georgian townhouses, once you get up to about 3 stories, if you're using a 10 mil bedding of mortar, it's actually going to start being problematic when you get too high up. And so therefore it's got low compressive strength. We don't generally use it in foundations or anything like that. The other advantage of it is it has a high vapor permeability. Therefore, it will allow some vapor to move through it. Now, when we talk about vapor, some of that vapor may contain moisture in some various forms. So it's actually able to move through this material. So that's another advantage. It's not completely, if you like, we could say it's not waterproof. It manages moisture by this permeability. However, the other advantage is that it's elastic. In other words, it can move around. And therefore, you will sometimes see some buildings that have undergone settlement historically, and the building can be quite distorted, but you won't see any cracks because the mortar itself has flexed with the building. So those are the advantages generally with air limes, lime putty, whatever we care to call it. Now it comes, as we've said, in lime putty is the most common form. Now there is another form that you might see, and you'll see it at builders merchants, and that's bagged lime, and it's dry hydrated lime. Now that is formed simply in this slaking process by using not a lot of water. So it's just enough water to slake it, but not to create a putty. And what you end up with is a lime. Now, that is obviously a form of lime, but it's quite ready to react, and it has to be thought about very carefully about when you're going to use it. It's not an ideal product to use in every situation. So we'll talk about its use later on, but that's just to say that bagged lime is actually an air lime. It's just a hydrated air lime. So that's an overview of air limes, and how we might use them in historic buildings we'll come on to in a minute. But before we get to that, it's important that we now think about the, if you like, the impurities and things we can add to it. So now Rich, our resident geek, is going to do the science on this and talk us through pozzolans and what were they, silicates and all manner of impurities. So Rich, over to you.
Thanks, Stephen. So Stephen just talked about the purest form of the lime, essentially. And what I'm going to just cover briefly here is then the impurities and how that fundamentally changes the properties of the lime and how it works from a chemistry perspective. So one of the terms that Stephen just mentioned that you may have heard before is the term of pozzolan. Now, it's a very unusual word, and I've looked it up, and effectively that a word originates from the ancient Roman town of Stephen, can you help me? I mean, you may not. Pozzoloi, Pozzuoli, which is located in the Bay of Naples, and that's where the word originates from, which essentially is where different impurities added to lime to actually give it a different property, more a cementitious type property. They're often powders, so they don't do much on their own, but when you mix them with lime and water, they actually chemically react to form different compounds that set and harden. So as examples of the sort of pozzolans we're talking about, you've got brick dust, which could be from crushed terracotta or from clay brick, volcanic ash, which is the classic Roman example and what they often used to use there, fly ash, and we'll come on to a bit of that later on, and metakaolin, which is a sort of refined heat-treated clay. So the chemical reaction itself, these materials contain silica and alumina, and they combine with the calcium hydroxide to form calcium silicate hydrates or calcium aluminate hydrates, the same type of compounds that are found in hydraulic limes and cement. So in short, they make the lime set hydraulically. That is, they set in the presence of water, not just the carbon dioxide from the air. Now, what does this do to the actual mortar itself? So it increases the speed of setting. That is clearly very useful when we're talking about buildings. Certainly, when time is money with the build sort of side of things, you can't afford to wait many weeks as we can or we used to be able to do to be able to build these buildings. The other thing it also does is it actually increases that compressive strength. So when Stephen mentioned just now in terms of how high you might be able to go with the building, actually this increases that ability to go higher because you can get much more compressive strength into these types of mortars. But here's the possible downside: it does reduce the sort of solubility or the permeability of it. And that's something that we'll cover later on when we're talking about natural hydraulic limes as well, in terms of how they manage moisture through the pores and the capillaries. It does also help with the durability, certainly in damp and exposed conditions, because it's a harder and a stronger mortar. It does help with when you're in extreme conditions with regard to weathering, they are much more durable in that regard. As a historical context, these aren't new. So the Romans used volcanic ash in lime to build things like aqueducts and harbours, and those structures are still standing today, and you can see some amazing examples of those. But we also see pozzolanic additives in medieval mortars, especially near kind of coastal or industrial sites where brick or ash was readily available. Now, why is it used today then? Well, actually, it allows us to customize the mortars for specific needs. So it's great in damp locations, for backing coats, for possible base plasters, or for high traffic areas because of that durability. But it needs to be done deliberately and proportionally. Too much pozzolan gives an overly hard mortar. Not enough possibly gives you not enough the strength and the qualities that you're after. Now, this is the perfect segue now into natural hydraulic limes, which is what Stephen's going to now cover, which is, of course, another way to get a hydraulic set, and that's by using natural hydraulic limes. Stephen, over to you, sir.
Right. Okay. So naturally hydraulic limes. Let's just go back and just think about, a few hundred years ago. There weren't railways, they weren't great roads, and there might have been rivers, but not a great canal system. So, say 400 or 500 years ago, the only way we're going to transport things is horse and cart, really. So, you're not going to go very far. And so, what we are going to find in most buildings, unless you're very, very rich, you're not going to transport things too far because it costs too much, quite simply, and therefore going to use local products. Now, when it comes to things like lime, you will use what's available. Now, we mentioned earlier pure lime. Now, if you happen to be in an area of limestone with a lot of lime that is very pure, that's great. And you're going to get a really nice pure lime putty. That's great. However, I come from East Anglia. We don't have limestone, but we do have chalk. However, that chalk is right next to clay. And often we get what we call boulder clay, which is actually a bit of a mixture of both. You get chalk and clay mixed in. So what happens if your source of lime is not pure? And often it will have clays and silica impurities and things like that in it. So you're starting with an impure source of calcium carbonate. Okay, so when you burn that, you're going to get the impurities in the mix. And what we end up with is what we call a naturally hydraulic lime, because it's got those impurities that Rich was just talking about in the terms of pozzolans, where we deliberately make the lime impure, if you like. But here, it's naturally impure. It's naturally hydraulic. Okay, so within that, we have various classifications. I mean, historically, they wouldn't have had any of these classifications. And I suspect they just got to know what their local lime was like and how to use it. So I think sometimes when we're dealing with historic buildings, we need to think carefully about what we're using. Because if we're dealing with a building in an area where there would never have been a pure lime, would a pure lime mortar be the best thing to use for its conservation? Questionable, it's debatable, certainly. But anyway, in modern times, we've started to classify naturally hydraulic limes, and we have a bit of a scale. So at the feeble end, what we call feebly hydraulic, is the NHL2. Okay, and that is going to set, as Rich has described, it's going to be feebly hydraulic. Now, at the other end of that scale, we have NHL5, which is what we call eminently hydraulic. And that is, if you like, closer to a cement mortar or that type of thing. And then slap in the middle, we've got NHL 3.5, which is what we call moderately hydraulic. If we had a scale of 0 to 10, and 0 was our air lime, pure air lime, then we had our 2, 3.5, 5 naturally hydraulics, and at maybe the 10 end is our cement. That's fine, and that's a nice, easy way of thinking about it. But I think we've now discovered that over time, these naturally hydraulic limes actually set harder and are less vapor permeable than we previously thought. So that little set of NHL 2 3.55 has shifted slightly, a little bit towards the cement end of that scale, and we need to bear that in mind in use. Now, we're going to cover that in another video, but for now it's worth knowing that we have these different naturally hydraulic limes. Now, they do have some benefits, i.e. strength, but that comes at a cost. The vapor permeability and flexibility is compromised slightly. The advantage is the set times, it's a bit quicker, and perhaps slightly less weather dependent, so you can use it for a slightly longer period during the year and not so dependent on having brilliant weather. So those are some of the things we need to think about. But hopefully that's given you a flavour of what a naturally hydraulic lime is. Do you think that's sufficient, Rich? Yeah?
I think it is. I think the only thing that is worth pointing out is what the kind of 2, 3.5 and 5 means with regard to specifically the compressive strength.
And that's where the numbers came about. So, yeah, thanks for that, Rich. Now, a lot of people then start saying, well, what about if we add cement to it? So we've talked about pozzolans, we've got naturally hydraulic lime, so therefore cement. What's wrong with adding that? Well, in a sense, there's nothing wrong with adding it, and that has been done since cement was first discovered. No, not discovered. It was invented. Portland cement, as we now know it, was invented actually in the late Georgian period, and they were experimenting with it and using it in various different ways. It wasn't called Portland cement at the time. They had various different names for it depending on who was producing it, etc., etc. But it was used throughout the Victorian period, and it only really came into its own as Portland cement as we know it today in the 1920s, and that's primarily due to the British standards coming about. So that's when it became what we know today. However, it's been around for a lot longer than that. And of course, as Rich has said, the Romans were experimenting with pozzolans and effectively making a form of cement with pozzolans back 2,000 years ago. So cements are nothing new, really, but they have to be approached with caution, because adding a cement does add an impurity, and it is like a pozzolan, but it's actually far more reactive than a pozzolan. So whereas you might add a pozzolan and you have a slight reaction, you have that slight impurity, you add a cement, it has a quite a different impact. So we need to be very careful. But I've got several books. I don't know if you can see behind me. I've got a couple of books there, a number of books from the late Victorian period, early Edwardian period. And even then, and we're talking about 1880s, probably a bit earlier, and certainly by 1900, they were talking about the correct mortar to use was not a pure lime mortar, but a mortar that mixed in cement. 129, 116 were the sort of mixes they were talking about back then. Okay, so the use of cement, not new. If you're in a Victorian building and you think, oh, I've got a lime mortar, yes, but actually it's not a pure lime mortar, it's a hybrid. Now you might say, but I can't see any cement, doesn't look like cement. What we need to remember is that cement also goes through carbonation as it ages. And so therefore, if you've got an early Victorian mix that did have cement in, that cement content will not appear as cement. It won't look like cement. However, if you chemically analyze that mortar, you'll probably find that it's quite hydraulic. And that's the only way of knowing. And obviously, most of us are not going to, if you're living in a terraced Victorian house, you're not going to take your mortar out and get it sampled and chemically tested. But it is fair to say that during the Victorian period, a lot of cement would have been used that today we say, oh, it's lime. No, it was a hybrid. Okay. So does that help with understanding how cement came in?
It definitely does for me, and that's what I mean. I love the science of this, as you know, but you're much more into the history in terms of what historically has been used and how that's worked in over the years with your 40 odd years of being in the game and seeing when it doesn't work, kind of thing. But I totally agree in terms of understanding both is really key, both the chemistry but also the historical context as well. And some of those purists that sort of say it must be this, it must be this, it's kind of like, well, it probably wasn't that when it was built. And I think it's really interesting to sort of, to unpick that a bit in terms of really to get an understanding, which does unfortunately make it incredibly difficult for the average homeowner in terms of what do I use, especially if you're wanting to DIY something. That's a tricky thing, which is one of the reasons why we make these videos, to sort of say, here, get some learning, get some understanding. But I think it'd be nice to pick up on some of the specialist lime mixes that we have these days, because there are lots of additives that both were historically used and we can be added even added now with some of the bag mixes. So beyond your standard air lime and hydraulic lime mortars, there actually are some much more specialist mixes out there, especially when things like insulation, strength, and speed is needed. These can be really effective, but they have to be carefully specified, just like any other product. So let's start off with insulating lime plasters, so things like hemp lime and cork lime. These mixes combine usually with an NHL2 or a pozzolanic lime, as I mentioned before, with lightweight aggregates. Now, those can be hemp shriv, those can be cork granules, or expanded glass or perlite, a bit less traditional, more modern, but actually really great for with wonderful properties of insulation. The purpose of those is actually to reduce the thermal conductivity. So, of course, you're retaining that heat within the building, and the plaster is actually helping to provide an insulation there to not lose it to the outer world. They can be really useful in heritage buildings where your standard insulation may not be vapor permeable or may not be suitable. So your PIR board insulation doesn't manage moisture very well, but actually if you add a little additive to the blind plaster, you can actually add some insulating value and maintain those properties of moisture performance, which is really useful. The advantage, great vapor performance and vapor permeability. They also help regulate that internal temperature and the humidity. And they can also reduce any cold bridging. So you can put around particular areas by packing them up or extending a slightly thicker plasters in areas, reducing those areas where you might get a thermal bridge. In other words, an area that's at higher risk of condensation. Some of the limitations, though, is they're not very load bearing. So you can't really use them for thick mortars. You can't really necessarily, they can be difficult to hang shelves from, for example, if you've got a big, thick sort of big wall of thick internally insulated plaster. They're also often not suitable for very fine finishes. So for very exposed areas, they can often not weather particularly well. So for renders, they're not particularly great, possibly more for internal plasters. They also need careful detailing to make sure they work effectively as insulation. So in other words, the right amount of whether it's perlite or cork granules have to be added into the mix for that particular application, and the right thickness, because as we know, if you add too much insulation thickness to your internal walls, you can affect where the dew point falls within that wall and risk interstitial condensation forming in the wall. Whole different podcast on that, but let's leave that to one side. Hi folks, sorry to interrupt, but really importantly, to help support this channel and to continue to make the content that we're making here, it's really helpful if you click on subscribe and one of the buttons down here, and also click on the little notification bell, then you won't miss an episode that comes up. Also, giving us a like or thumbs up also helps indicate whether or not this is the kind of content you enjoy listening to. Right, I'll leave you to get on with the rest of the video now. Thanks very much. Okay, so I think that's wrapped up most of the insulating lime products. What I was then going to talk about.
Hang on, Rich. There is just one more that I've heard of in the past. Now, I don't know if it's still being used, but I went to a CPD talk about by one of the manufacturers, and I understood that they were using aerogel as the insulating additive. Now, aerogel is very expensive, so I'm not sure they're still using it. But what was also said is, as the aggregate, they're using chalk rather than sand. So there are variations on a theme here, and I think if you're looking at insulating plasters, look at what they include, what they involve. Some are going to be more expensive, like an aerogel plaster will be quite expensive because the aerogel is expensive, but it might have better insulating qualities. It depends what you're after. So I think the important thing here is to do your research when you're looking at some of these. Okay, sorry to have interrupted you.
No, it's useful to add it in there, definitely. I mean, I've seen some videos on aerogel. It's a phenomenal material. What we don't know about aerogel, though, is its longevity. in terms of how it performs over decades, because of course it's not been around for that long, and how it's made, of course. But yes, I mean, so I'll carry on with pre-mixed lime systems, so things like eco limes and hybrid products. Now, there are commercial systems that are designed for conservation and eco builds specifically. They're bagged mixes that combine lime with natural fibres and pozzolans, or even some other modifiers. They offer consistency, convenience, and often some improved thermal or setting performance, but they still need to be selected based on context. You can't just pick one up on the shelf without thinking about the substrate, the exposure, all the other intended purposes, the moisture performance. And that's why this is really quite a technical area to specify what you're going to need for your particular building. Okay, I'm going to wrap it up now in this particular section. So specialist limes and hybrid mixes can be really useful tools, but you've got to know what they've gone into them, as we just mentioned. You've got to know what their performance is, what the pros and cons of using each other. Otherwise, you do risk getting a product that's actually totally wrong for your wall and actually can cause issues with, like I said, interstitial condensation, with setting too hard, all sorts of other areas. So it's quite a complex science and history in terms of what needs to go into it. Right, Stephen, over to you to talk about what we're going to go next.
Right, so to recap on what we've talked about in this video, we've said that the type of lime used is fundamentally important because it affects the performance. However, as you've heard, there are lots of different types of lime, and therefore you need to understand all these different types and what might be best for your building in a given situation. Now, in the next video, we're going to talk about the actual application of limes. So in this episode, we were talking about the different types of lime. Hopefully you found that interesting and helpful. Now, the next episode is going to be talking about the use of lime in things such as mortar, render, for pointing, and so on and so forth. So that will be the next episode. We look forward to seeing you then. And of course, if you want to be reminded about when these come live, then please press subscribe and like. Thank you very much. See you again soon.